This is the second part of our topic under linear momentum, and it will be based on collision of two or more bodies. And we are going to start it from the principles of conservation of linear momentum. You know the meaning of momentum that we have done before in our previous video, that is the product of mass and velocity of that body. And don't forget, we later proved that that momentum is the same thing as impulse, which is equal to what? Product of force and time during which it was act. Therefore, the momentum is equal to, that is mv is equal to ft. But today's home, we are going to start by stating conservation of linear momentum. When we are talking about conservation of linear momentum, the principle says in an isolated collision, that is, if there is no external force on that collision, the momentum before collision must be equal to the momentum after collision. That is, the sum of momentum before collision must be equal to sum of momentum after collision. That is, if you have two bodies, this moving with initial velocity u and mass what? m1, that is u1. Then this one too, that is m2 with initial velocity u2. Then, if there is collision between these two bodies in an isolated system, that is, the momentum, the sum of momentum here, m1 u1 plus m2 u2 must be equal to the sum of the momentum after collision. Therefore, after collision, we are going to have, let's say we have this, then the mass still remains m1, m2, then the final velocity here, v1, then v2. Therefore, this one must be equal to m1 v1 plus m2 v2. That is, if there is no external force. Once again, principles of conservation of linear momentum says that in an isolated system of collision, the sum of momentum before collision is equal to the sum of momentum after collision. This one will now lead us to the type of collision we have. We have two major types of collision. We have two major types of collision. That is, we have elastic collision and inelastic collision. And then, how are you going to identify the collision, whether it's what? Elastic or inelastic? You can easily get that. What you just need to do? Calculate the kinetic energy of that system before collision and after collision. That is, before collision, we are going to have kinetic energy half m1 u1 square plus half m2 u2 square must be equal to half m1 v1 square plus half m2 v2 square. That is the sum of the kinetic energy of the two bodies that involved in the collision must be equal to the sum of kinetic energy of the two bodies after collision. In that case, if the two are equal, you now finalize that that kind of collision is what? Elastic collision. Otherwise, we call it inelastic collision. Then, we still have what they call perfectly inelastic. That is when the two bodies stick together and they are moving with what? Common velocity. But for the sake of this topic today, we are going to base it on the elastic and inelastic collision. That is, in summary, for elastic collision, so this one, momentum before collision can be equal to momentum after collision. And kinetic energy before collision also will be equal to kinetic energy after collision. But inelastic, you can have this one to be conserved. Momentum before collision and momentum after collision can be conserved. That is, they are going to be equal. They can be equal, but this kinetic energy, the moment you discover that kinetic energy, the sum of kinetic energy before collision is not equal to the sum of kinetic energy after collision, we call that kind of collision as what? Inelastic collision. Then we now have different ways by which objects can collide together. And the problem is, students normally have problem in how to form the equation on how to solve the question. when it comes to what? The term of collision of two bodies. Now we are going to have different forms by which body can collide together and how you are going to get the formula for them. Now, let's start. Let's say we have a body A, let's say we have this body, then we have this one before collision. We are going to use arrow to indicate the direction. If this one is going like this, and this one also is going like this, if after collision, so this one also in this direction, then the second one also in this direction, then what would that be the equation? It's very simple. Just use this arrow, that is their direction, to derive the formula. If this one is our M1, then this is M2, then M1, M2. In that case, we are going to have M1, we are following this direction. U1 is plus M2, U2 is equal to, then M1, V1 plus M2, V2. Then out of this parameter, they will give you at least almost all, remain only one that you are going to calculate. They can give you two unknowns. So it's very simple. Then it just depends on how you are going to form out the formula. Then let's have another type. Let's say we have this in this direction, then this one coming like this. Then after collision, if two of them move in this direction, then how are we going to generate the formula? So this, don't forget, M1, M2, M1, M2. So to that word, this one will be M1, we are following this arrow, this direction. M1, U1, then since this one is coming like this, it's moving in opposite direction. So we are going to change it to what? Minus M2, U2 is equal to, then this one is in this direction, to be plot. That is M1, V1 plus M2, V2. That's all. Then what of if you have it like this? We have this one going like this. Then we have this one coming in this direction. But if after collision, then this one back like this, then this one like this. Just follow the direction. So this one we have is in this direction. I will have M1, U1, but since this one is opposite to this, it will be minus M1, M2, U2 is equal to, then this one too in this direction. It will now be minus M1, V1, then this one is plus M2, V2. But in this case, you can write this one first and put this one so that it will be M2, V2 minus M1, V1. Whichever way, you will surely get your correct answer. But the next one, let's say we have a body like this. Then this one is going like this. Then we have this one going like this. If after collision, this, then both of them move in the same direction with the same velocity, then how will we now derive the formula? This one is telling us that this and this, they are moving with the same velocity. So in that case, let's represent their velocity with what? V. So you are going to have M1, U1, see the direction, plus M2, U2 is equal to, since they are moving in the same velocity, so you factor this velocity out, V, open bracket, M1 plus M2, close the bracket. So this is what will be the result. Next time, they may ask you to find their common velocity. This is what they refer to as common velocity. And this type of collision is called coalition. That is, they collide together and they are moving with the same velocity. Now let's try to check another form. We can still have it like this. We have this one, we have this is M2. So after collision, So like this one is coming like this, because this one is coming like this one is like this. So we have, just look at the arrow. So and you get this one, how you are going to put arrow from the question itself. So this one will now be M1 U1 minus M2 U2 is equal to minus B open bracket M1 plus M2. So depend on the question. Once you can interpret the question like this to get the formula, it's very simple. You just make sure that your formula follow the direction you indicated on the diagram. Very simple. Then the next one is applications of Newton's law and principles of conservation of linear momentum. Then you can see that's why the recording of the gun, that's one of the applications. See that when they are shooting the gun, the bullet will move with what? High velocity, because the mass is very small. Then the gun itself, because the gun has what? High weight compared with the bullet. Then the velocity of the gun that will make it to recoil back will be very small. The same thing with when we are walking. So what make our walk possible? That is action and reaction from Newton's law. Then jet propulsion is part of those are the application of Newton's law and conservation law of linear momentum. Then the next topic will be based on why or NEPO question on the conservation of linear momentum.